Okay, so today I'm going to teach you how to solve for x where you have the fractions, where one of the terms it could be a fraction. Maybe let's consider this to be example number 1, where you are given, let's say, 1 over 2x that is being added to 7, and this being equals to let's say 4. So just like we did with simple linear equations where there were no fractions involved, we knew that in the end we have to have numbers on one side and letters on one side. We still follow the same principle even when we are dealing with this type of an equation where one or more of the given terms may be a fraction. So obviously it's half a letter, so we just leave it on the left hand side because that half is attached to a letter. On the right hand side you have a 4, you take 7 to the other side, it changes its sign, it becomes minus 7. You still have your half on the left hand side, you just need to work out this on the right hand side. Definitely 4 minus 7 will give you negative 3. This is where you need to be careful. So you've got many ways in which you can work it out. Remember, it is the half which is attached to the x, so that means you need to detach this half. So one of the options is for you to divide on both sides by half. The reason why you would divide on both sides by exactly that half is so that it cancels completely. So that means that half cancels completely with that. Then you remain with x being equals 2. Then you have that negative 3 over a half, which might end up as negative 6. But you can punch it on your calculator, or you can just work it out where you say negative 3 divided by a half, and then you multiply where you swap the 1 and the 2, and it ends up giving you that final answer of negative 6. So what I mean is, if you have that negative 3 which is dividing that half, mathematically we know that it should be the same as negative 3 where you multiply. So you change that division sign. That means as you change it, the 2 goes to the top, and then you say over 1. So now it clearly looks like you are going to have a negative 6 because you end up having that negative 3 multiplying that 2, which ends up being negative 6, and that should be the end of it. So as we continue, you will therefore notice how to deal with such where you get to almost the final answer. So now let's say you have negative 3 minus 2x over 3, and this being equated to, let's say, negative 4. Again, in this case, you will definitely leave the negative 2x over 3 on the left hand side equals to negative 4. That 3 will come to this right hand side, it changes the sign, it becomes positive 3. You still have your negative 2x over 3 being equals to that plus that, it will definitely be negative 1. Remember, it's always best to punch it on a calculator in case if you are not sure. So something very much important, remember that when you have negative 2x over 3, it is still the same as negative 2 over 3, and this x being there, which is still equals to that same thing. So the reason why I'm doing it this way, it's so that I will say let's divide by exactly that negative 2 over 3. I'm sure by now you know why. Obviously, what you do on the left, you do on the right. So the reason why you divide by that is so that the whole of this can cancel completely with that. Then you remain with your x, which will be equals to, can punch that on your calculator. It should give you positive 3 over 2. Let's see, when we punch it on a calculator, it's negative 1 divided by, in brackets, it is that negative 2 over 3. Yes, it gives positive 3 over 2, and that should be the end of it. Maybe let's look at another example and see how far we can go. Let's say, as example number 3, we have 3x divided by 4, where we minus 5, and this is equated to 1. Again, you want to have your letters on the left, numbers on the right. So it is for this reason why I will still write that 3x over 4 on this side, and then already on the right hand side I have 1. I will take this to the other side, it will change the sign, it becomes plus 5. And then what you do is just to remember that this is still the same as that, and then this plus that, definitely that is 6. So what you do, you detach that fraction of that. Remember, whatever that you do on the left, you also do on the right. So that means the whole of this will cancel with that. Then you've got your x being equals to, how you punch this on your calculator, you can just say 6 divided by, in brackets, 3 over 4, and it will definitely give you an answer of which it is 8. So that's how you would work it out. Maybe without wasting much of our precious time, let's move on to another example. In this case, I'm having it as example number 4. So example number 4, let's say you have 6, which is equals to, in this case, we can still say that. And then maybe let's add it with 2. Okay, then it's fine. This is what you are given. Remember, letters one side, numbers one side. So you can still take these 2 to the left hand side, so it doesn't really matter that much. You can say 6 minus 2, and this is equals to. Most importantly, you have an invisible one there. It may look like it is just x over 5, but please be aware that it is actually the same as 1 over 5 multiplying that x over there. So that means when it's written like this, that x, it always multiplies the numerator, or in short, the letter always multiplies the numerator being the number above the over, and then the one below being the denominator. So it's like, now I've rewritten it in this way, so that I will say 6 minus 2, definitely that is 4, being equals 2. Then I know that I'm going to easily detach that 1 over 5 by simply dividing by. You can see I'm putting it inside the brackets just to eliminate chances of making any mistakes when I have to either punch it on a calculator or work it out with the other one on the other side. So you can see that's how you detach a number, which could be a fraction or whatever the case may be, to a letter. So you end up having that letter x being equals to, punch it on a calculator, 4 divided by, inside the brackets, 1 over 4 equals 2, and then we are having 20 there. So if you remember, I said it's best to write it as letter equals a number. Something that you might need to easily remember, it's like you're saying Desmond is my name. When it is written in this format of 20 is equals to x, but rather write it this way and say actually x is equals to 20. So in this way, it's like you say my name is Desmond. So I hope you fully understand it. So now Let's continue with another example, maybe this being example number 5, where you may be given 2 minus x and the whole of that being divided by 3, and that being equated to 4. So in this case, you can see that you just have one term on the left hand side and you also have one term on the right hand side. You can do it in many ways, but maybe let me just show you, and not necessarily an easy way to go about it, because there are other ways which maybe seem to be easy. But how you work it out, you just cross multiply, force this one on the right hand side to be a fraction. You see there you have that over that. On this side, to force it to be a fraction, you divide it by 1, just so that you can cross. When we say cross, it means this cross to multiply that, and this is the bottom cross to multiply that. So it's like that one will be multiplying that 2 minus x equals to that 3 will be multiplying that 4. It doesn't matter if you say 4 times 3 or 3 times 4. Then this is where you now do this by that, that by that, just so that you remove the brackets. Definitely you will have 2 minusing 1x there. That times that, it will definitely be 12. Then now you can take this 2 to the other side. You remain with negative x, which will be equals to, obviously 12, that 2 changes the sign, it becomes minus 2. Then please remember that you have invisible 1 there. So let's just write it as invisible 1x being equals to that minus that. It will definitely be 10. Now you need to detach that negative 1. Can you see? You detach it, it removes completely. Then your x will be equals to 10 divided by negative 1. It will be negative 10. Looks to be a longer method, but trust me when I say, if you do it this way and get used to doing it this way, trust me, any type of a math problem that looks like this, you will easily work it out, and you will even be able to understand some more complicated problems. So let me just continue to do some more and see what would be expected of you to do in case if you are given something a bit different. So let's see. Let's say this would be example number 6. Let's say you are given x, maybe this is being divided by 6, where we minus 5 over 2, and this being equated to negative 1. Remember, the fraction that is a letter, I would rather leave it on the left hand side, and then already I'm having negative 1, which I will plus it by 5 over 2. So the 5 over 2, I'm taking it to the other side. Remember, you have invisible 1 there. That is why it would be best for me to write it as that, just so that it therefore becomes easier for me to detach it. But negative 1, when you plus it with 5 over 2, it gives you that 3 over 4. So that means you have positive 3 over 2, not over 4, but over 2. So it is now up to you in terms of how you work it out. One can still say, now I'm going to detach that 1 over 6. So remember, whatever that you do on the left, you also do on the right, or vice versa. So that's how you detach that 1 over 6, and then you end up having your x being equals 2. You can punch that on your calculator and say 3 over 2 divided by, in the brackets, you will therefore say 1 over 6 equals 2. It therefore gives you 9, and that should be the end of it. I hope that makes sense. Remember, this is not the only way to work it out, but as I've indicated previously, I'm training you on finding the correct final answer. You might find that your teacher wants you to use a different method. It looks like I'm running out of blank pages there. Maybe let me try to erase clear. And then now that I've erased, let me just add some more pages just in case. I'm going to be having some more examples. Okay, so now let me just make sure that I'm writing on the page. Okay, so now let's say this to be example number 7, where let's say you have negative 3 over 4x. Maybe let's add it to 2. Then let's say this is equals to 1 over 2. Yes, let's say it is equals to 1 over 2. Again, this negative 3 over 4x, I will just leave it on the left hand side. And then I will therefore say this 1 over 2, I will take that 2 to the other side. Definitely, it will have to change its sign. And then you now have your negative 3 over 4x, which will be equals to half minus 2. Definitely that should be what is it, negative 1.5, which is negative 3 over 2. Let's see, negative a half, not negative a half, but half minus 2, yes, negative 3 over 2. So I think by now you do know very well that I'm going to divide both sides by that, just so that I can detach it. Then this should be equals to, on this side I'm having that negative 3 over 2, where I need to divide it by that, just so that this will cancel completely with that. And then I'm just trying to figure out how I've written this. It looks like there is something that I've done which I was not supposed to do. Okay, let me rewrite this in a way that will not leave you with some questions or uncertainties. I will actually want to start it from this step, yes, where the next thing to do is for you to detach that. So you will divide by exactly this same thing, just so that it will cancel. Whatever that you do on the left, you also do on the right. I think this is a proper way of writing it. Negative that over that, just so that this will cancel completely with that, and then you have your x, which will be equals to, you can now try to punch that on your calculator, where you say negative 3 over 2 divided by, in the brackets you have your negative 3 over 4, and that it is equals to 2. So that's how you would work it out. Maybe let's squeeze in the last example, and then from there we will see if we can find something a bit more challenging. So let's say here we have now 5 minus let's say x, that is being added to 1, and then that being over 3, and this is equals to 2. So it shouldn't be complicated, because I will just take that 5 to the other side. So that means here I'll just remain with that, which should be equals to, then 2 minus 5. Then I'm definitely having my negative x plus 1 over 3, which is going to be equals to, definitely this will be negative 3. Already you have negative on the left and on the right, they can just straight away cancel. Then if you remember, I said you can therefore force this one to be a fraction, because you now have x plus 1 over 3, and then on the right hand side that and that, which is where you now cross multiply. And you know, when you multiply by 1, it remains as it is. It doesn't change. 3 times 3, definitely that is 9. then you end up having your x being equals to 10. That should be the end of it. Nope, not 10. Why am I saying it's 10? It should be 8. You see the problem with not doing a full step, you end up making mistakes. You need to take this to the other side. It will become 9 minus 1, where x it is equals to 9 minus 1, that is 8. So that should be the end of it. I think I've covered all that I wanted to cover, and I don't think there's anything that I've missed out. It looks like I've covered all that I wanted to cover for now. Okay, then it's fine. This one I will just leave it here. Okay, so today I'm going to teach you about theorem of Pythagoras. Not that much complicated. I'm going to make sure that you fully understand it without having any doubts. So, something that you need to be aware of is that when it comes to theorem of Pythagoras, we are mainly looking at a triangle, not just a triangle, but a special one called a right-angled triangle. Maybe so that you fully understand why this specific type of a triangle, let me just make a drawing there to say if you have this, definitely it is a triangle. Why? Because it has 3 sides and 3 angles. This is a side, this is a side, this is a side, an angle, an angle, and an angle. So that means a triangle, it is this type of a shape that has 3 sides and 3 angles. So the special type of a triangle that we are going to be looking at, it is this one that has a 90 degree there. You see, at that corner, it should be that box. This is the only thing that tells you that you are now dealing with a right-angled triangle, where one of the inside angles is equals to 90 degrees. So it doesn't matter if it is positioned like that, as long as it has this, then we know it is a right-angled triangle. Then if you have something which looks like this, ask yourself a question to say, is this a right-angled triangle? The answer should be yes or no. Maybe take a guess. Is this a right-angled triangle based on what I've explained up to this point? Nope. Definitely not a right-angled triangle. Why? Because it does not have that. It does not have that. Even though it looks like it is a right-angled triangle, as long as it does not have that, number one. Number two, as long as there was no statement which says consider a right-angled triangle below, then it is not. We just say it looks like. Yeah, it is just a triangle which looks like it is a right-angled triangle. But the moment we have that, then we know it is a right-angled triangle. I hope that part makes sense. So maybe on the next page, let me just go deep and focus on a right-angled triangle. Something very much important. If you have that type of a triangle which is not a right-angled triangle, until we do that, then now it is a right-angled triangle. Obviously we know that it has 3 sides and also it has 3 angles, and one of those angles it is equals to 90 degrees. That's where you have that corner there. So Again, something that you should be aware of is that when it comes to the sides, side 1 we can refer to it as side 1, and again the second side we can refer to it as side number 2. But this longest side, it has a name. The longest side, it is called hypotenuse. The question now is, how are you going to know which side is hypotenuse? Hypotenuse is always the side which is facing that 90 degrees. So that means you might be having a right-angled triangle which is like that. What you know is that the side which is facing that 90 degrees, it is the longest side, and again it is called hypotenuse. So that means when you take side 1 in terms of its length and you compare it with the hypotenuse is always longer. When you compare it with that, it is always longer. So now, maybe for the last time, let me do this and say, doesn't really matter that much in terms of how the right angle triangle is positioned. What we know is that the moment it has this, then it's a right angle triangle, and most importantly, this is our hypotenuse, or the longest side, with this being side 1 and that being side 2. These other sides, they also have the names, but for today we will just leave it as side 1, side 2, and the longest one being hypotenuse. Maybe let me add an extra page there, so that we can now start looking into the calculations. So there is a formula that we use in order to calculate the sides of a right angle triangle. And the formula can be written in many ways, where, for example, they can say, maybe let's use h, which represents the hypotenuse. So that means that hypotenuse side squared should be equals to side 1 squared that you plus it with side 2 squared. Sometimes they can write this formula as r squared being equals to x squared plus y squared. It really doesn't matter that much in terms of how you write it. It all depends on what you are given and what you are trying to calculate. What we know is that that h represents the hypotenuse, which is equals to h squared equals side 1 squared plus side 2 squared. So let's maybe look at a right angled triangle and see the calculations involved. So it must have that for it to be a right angled triangle. Maybe they can say that point is A, this one is B, that one is C. It doesn't really matter that much. Maybe let's say this side it is 2, and then this side, let's say it is 3. So you can already see that you have two sides. The third side is unknown. That unknown side, is it the hypotenuse or is it just a leg or the side? It is the hypotenuse. Why? Because it is the side facing that 90 degree side. So now, in terms of the formula, you can create your own, whereby you say side AC. So that means your side AC being the hypotenuse, but you will say side AC squared is equals to, then you can choose any side in this case. You can start with side AB or side BC. Doesn't really matter that much, but what you need to make sure of is that it is the hypotenuse squared equals to adding those two sides each squaring. And then now let's say you decide to say it will be equals to AB squared that you plus it with BC squared. So can you see, whether you use this formula or you use that formula, it doesn't really matter that much. So the x, you can substitute your 3. If you don't want to substitute the 3, you can still substitute that. What matters the most is that one side is there and then one side it is there. So now let's see. If we have to now continue with substitution, what is side AB? Definitely side AB, it is 2 plus, what is side BC? Definitely that is 3. So can you see, it makes no difference even if you had, let's say, 3 squared plus 2 squared. It's like you're having 2 plus 3, which is the same as 3 plus 2. I'm just giving you an example there to say it doesn't really matter that much in terms of which side you substitute and where. Okay, then it's fine. So what is 2 squared? That is 4. What is 3 squared? That is 9. So it looks like you have that plus that, which will be 13. So with you having 13 there, remember that 13 all along you've been calculating AC squared, AC squared, AC squared. So it is the AC squared which is equals to 13. So now you need to remove that squared. You will always put a square root. On your calculator there should be a square root where you will know that now that squared has been removed. You see that AC squared, that 2 at the top has been removed, and then you just remain with, if you punch square root of 13 and it gives you square root of 13, then you just leave it as it is. You don't need to write it as a decimal. You just leave it in that format of a square root, unless if it was specified to say a final answer should be a decimal, maybe round it off to 2 decimal places, but if not, you just leave it as it is. So let me do another example real quick and say we have something of that nature there. And then maybe let's say this is 5, maybe this side it is 2. So the side that we need to look for, let's call it side X. So obviously, since you are given that side X, you can still say, okay, my R squared is equals to X squared plus Y squared. Which side is hypotenuse? It should be the one facing that 90 degrees. So that means that's where the 5 goes into the formula. And then that side X is the one that you are looking for. Plus, what is the Y side? It will be this one of 2. So you end up having 5 squared, which is 25, equals 2x squared. What is 2 squared? Definitely that is 4. So now you start solving just like I've taught you, where you need to make sure that numbers one side, letters one side. So you can take the 4 to the other side, where it becomes 25 minus 4 being equals 2x squared. That minus that, definitely it is 16 equals 2x squared. Now you need to remove that squared. So you will always follow this process, where now you have your square root of 16, that will definitely give you 4, and then that's how you've removed that squared. So that means x is equals to 4, and that is the end of it. So now I've just made calculations in 2 ways, where you calculate a side or where you calculate the hypotenuse. So let me just hold it here for now, and then I will do another example. Okay, so let me add an extra blank page there to try and do one more example. Okay, maybe this one, let's say you have something of that nature, and then you've got that, confirm it is a right angle triangle. And then let's say you have 1 meter, and then after you having 1 meter there, let's say here it is 3 meters, and then here they say you are having P. So please be aware that you've got your hypotenuse side being that one, and then you've got 2 sides. What you know is that you can use this formula which says r squared equals x squared, and that you plus it with y squared, and then easily substitute. You've got your 3 over there, and then your x value can still put 1 there, plus, and then your p squared. Then 3 squared, definitely that is 9, which is equals 2. What is 1 squared? It is just that. And then p squared, that's what you are looking for. 1 to the other side, 9 minus 1, definitely that will be 8, which will equals 2. Definitely p squared. Then what you can do now is to square root both sides so that you remove the square root on that other side of p. And then for 8, if you say square root of 8, you check what it gives you. If it gives you a decimal, do not write it as a decimal, it's fine, you can just leave it as square root of 8. Then remember, this looks like Desmond is my name, then rewrite it as my name is Desmond, where you start with a letter to say p is equals to square root of 8, and that is not the end of it until you say meters. Why? Because all the other sides were given to you in meters, and now you are done. Okay, so now I'm going to teach you exponential expressions where you need to simplify. I'm very much excited to be taking you through this topic, but most importantly, you need to make sure that before you attend this session, it could be after, just make sure to revise the basic laws of exponents, because what I'm going to be doing now, it is to actually apply all that I taught you regarding the laws of exponents. It is actually those basic ones. So maybe straight away, let me look into the first example. Let's say, maybe let me regard this as example A, where you may be given, let's say 16 squared. I'm curious to know if I'm going to have enough space. I think it's fine, otherwise if not, I'll just add a new page. I will just see how it's going to work out, unless if I try to zoom in, and then after zooming in I might be having some space. Yes, I think what I will need to do is just to zoom in, just so that I can maximize on the available space. So let's see if I do that, and let me do that, maybe reduce that to that. Okay, let's see, example A, let's say we have 16 squared, where we multiply, remember that dot, it simply refers to a multiply, even the brackets refers to a multiply, and lastly the normal multiplication sign that you know. So those are 3 ways that you can multiply. Then let's say we have 2 to the exponent of 7, multiplying 2 to the exponent of 5, multiplying 81. So the reason why I'm never intimidated by this type of expressions is because it's like they take 2, and then elsewhere they take 4, maybe somewhere they take 9, then they combine them together to form something like, let's say 2 multiplying 4, and then they can just say over 9. So what I know is that 2 is to the exponent of 1, 4 can be written as 2 to the exponent of 2, which means there already we have 2 to the exponent of 2, and then 9, we know very well that it can be written as 3 squared, so that means this is the same as 3 squared. So that's how I always look at it, so that it doesn't look intimidating. So I'm therefore going to take you through this specific one. So remember, I'm saying this is an expression because you look at it, it doesn't have an equal sign. That is why it is an expression and not an equation. If it had an equal sign, it would be an equation. So since it does not have an equal sign, it means you are going to simplify. So the question now is, how are you going to simplify? You start with that base of 16. So the base of 16, let's see, what is 16 in a form of a base and an exponent? I think, let's see, is it not 2 to the exponent of 3? Nope, 2 to the exponent of 3, it's 8. Let's see, what about 2 to the exponent of 4? Yes, it gives 16. So that means what you do, it is to rewrite that 16 as 2 to the exponent of 4. Everything else stays where it is, exactly as it is. And then now I think based on that law where we said if you are having a base maybe to the exponent of x raised to another power, this is the same as you taking that base and you multiply those exponents. It is the same law that I'm going to apply here, where I'm having that 3 and then it is that 2 that multiplies the 4. So can you see I've applied that law. And then here it looks like already I'm having 2 and then 2 there as the base. Why can't I apply that law which says if you have a base to the exponent of x and it's being multiplied by the same base to the exponent of y, why can't you add their exponents? Instead of you writing a b and another b, write one b and then if those bases are multiplying each other, add their exponents. So you see there the base is 2. I'm no longer going to write 2 of them, but I'll just write 1 and then I will take those exponents and add them together. Then this one of a big base being 81, we need to rewrite it in a form of a base and an exponent. So what is 81? Let's see, is it 2 maybe to the exponent of 5? Let's see, 2 to the exponent of 5, 2 to the exponent of 5, nope. 2 to the exponent of 7, nope, is too much. 2 to the exponent of 6, nope, it doesn't work out. Maybe let's try 3 to the exponent of 4. Oh yes, it works out with 3 to the exponent of 4. So I've done it the manual way. There's another way in which you can easily do it on your calculator. I think you just punch 81, then you say equal sign or equals to, then it will give you 81. I think you click on shift, then you look for a button which is clicked which is written fact or F-A-C-T, fact, yes. Then it should give you 3 to the exponent of 4. But otherwise, worry not, I will definitely show you in terms of how you do it. Okay, then it's fine. So you will therefore say this is equals to. It now becomes easier because you've worked on it nicely. What you just need to do, again, you see, there you apply that same law where you need to multiply. So it's like you are having that 2 to the exponent of 4 has to multiply that 2. What will that be? I think when you multiply those 2, definitely it will be 8. And then you are having 3 to the exponent of that times that, definitely that is 8. Over, and then you are having 2 to the exponent of what is 7 plus 5? It should be 12, multiplying 3 to the exponent of 4. So all that you were doing, it was just to simplify or work out those exponents. So now the next thing that we need to do, very much important, if you remember, I said when you have a base to the exponent of, let's say, 8 over the same base, only if it is the same base, and then you have, let's say, to the exponent of 4. I said the smaller exponent visits the bigger exponent. That's how it works. So that means it is this small exponent that has to visit the bigger exponent, which means this exponent has to go to the top, and it ends up being b to the exponent of 8. Remember, you minus when you are dividing the same bases. Then it ends up being base to the exponent of 4, because 8 minus 4, it is 4. But in a situation where you have base to the exponent of 4 over base to the exponent of 8, remember that base, it doesn't matter what letter it is. It doesn't matter what number it is, as long as they are the same. So in this case, it means this 4 has to go to the denominator part. The statement remains: the smaller exponent will always visit the bigger exponent, which means in this case you end up having 1 at the top over b to the exponent of that bigger exponent, you minus the smaller exponent. So that means in the end it ends up being 1 over b to the exponent of 4, because 8 minus 4, it is 4. One may be wondering to say, where does that 1 come from? Remember, you have an invisible 1 there, so that's where that 1 is coming from. If you had 4b to the exponent of 4, that means there you are going to have 4. So in short, what remains, it is the coefficient that remains at the top. So let's now try to apply that. So that means this 8 will have to go to the denominator, where it minus that 12, and then this 4 will have to go to the top. In other words, it is 3 to the exponent of 8 that remains at the top, where you will need to minus that exponent of 4 from that 3. And then you will say over, it is 2 to the exponent of 12. You will need to minus that 8, because 8, it is the smaller exponent. You therefore end up having 3 to the exponent of, what is 8 minus 4? Definitely that is 4, over what is 2 to the exponent of 12 minus 8. Is it 4? I think it is 4. So finally, it looks like you end up having your final answer 3 to the exponent of 4, that is 81. I've just done it not long ago. And then 2 to the exponent of 4, definitely that is 16. So that means this is the end of it. So can you see, it's like you had different types of it's like you had different types of expressions or small expressions which were combined together to form a math problem, being that type of an expression that you had to work out. So I think that made sense. Maybe let me now jump onto the next one. You might as well take a screenshot so that when you do your short test, at least in case if you need to come back to this, you will then be able to redo this same thing that I've done before you attempt another problem which may be similar to this. So let me just add a blank page there. Let me just remember to zoom in, just so that at least I will be able to. Okay, I zoomed in too much, but otherwise it's fine. Okay, so let's say, maybe let's consider this to be example B, whereby for example B, let's say we are having in the brackets, let's say 2 to the exponent of x, then we close that to the exponent of 4, and then we multiply this by 9 to the exponent of x, and then we divide the whole of this by 12 to the exponent of 2x. So this is what you are given. Again, it is an expression because we don't see an equal sign, which means we are going to simplify. Then not only that, just think of it as you are given each of those but combined together. So what I know is that on that first part, I will apply that law which says when you have the base raised to a base and raised to another, not raised to a base, but a base raised to an exponent, and you have another exponent, you just multiply those exponents. So in short, I'm saying you have 2 to the exponent of that invisible 1x multiplying 4. So the 4 will multiply the 1. 4 times 1, definitely that is 4, and then because there's a letter there, you just write it as it is. Then this is multiplying 9. When it comes to 9, definitely 9, it should be 3 squared. So can you see, I'm doing that inside the brackets because I'm only changing the 9. So that's why you need to rewrite it or write it inside the brackets. Then you will easily work it out. And then when it comes to 12, you might need to remember that 12 may not be written as something raised to the power of something, but definitely if you do that way of saying you punch 12, then you press equal sign, you click on shift, then you click on that button which is written FACT, fact, I think, yes. Then you say equals to, you might find that it gives you 4 multiplied by 3. So that is how you can expand that 12. Obviously, it is to the exponent of 2x. So be careful and be considerate of how I've done it. It is 4 times 3, which is equals to 12, because it cannot be written as something being the base raised to whatever. So now let's see, in terms of the next step, you just keep on doing what you can do. So this base of 2, we can no longer further simplify it. It just remains as that as its smallest base. Then here you apply that law which says that times are that, which means you end up having 3 to the exponent of 2x. And then this is being divided by, very much important, be careful when it comes to this one. So you have a base which is a, and then another base being b. The reason why I'm saying a and b is just to show you that these bases are not the same. You've got 4 and you've got 3. 3 and 4 are not the same. That's why even with the letters, I'm using different letters. Therefore, if you are having whatever there, then this exponent, it will multiply the exponent of that base and again the exponent of that base, of which in this case will be invisible 1, invisible 1. So in other words, I'm simply saying you have 4 to the exponent of that invisible 1 multiplying 2x, that invisible 1 multiplying 2x, which means you have 4 to the exponent of 2x, because 1 times anything is the same as anything. Again, you are having that 3 where you are having that 2x. So you see, I've changed from that multiplication sign of cross to the one for the dot, because it is easier to deal with the one where you have a dot. Now let's see. So, notice something very much important. 4 can be written as 2 to the exponent of something. So, same time, I can modify, I'm just trying to save time, but on your next step, that means you can still rewrite that 4 as 2 to the exponent of 2. Everything else remains the same. I'm just doing that to save space and time. And then that means your next step would still be 2 to the exponent of 4x. Everything remains the same until everything is in its lowest base. So you see now that law again, it repeats itself. 2 times 2, it ends up being what? 4x, where you have that 3 to the exponent of 2x. I hope you are following what I'm doing there. And let's see, where do we go now? Why does it look like this will cancel with that and that will cancel with that? The moment things cancel out, then you just remain with 1. So that's how you end up having 1. Or otherwise, if you did not want to do it that way of cancelling, you can still say you have 2 to the exponent of that 4x, where you minus that 4x, multiplying that 3 to x, where you minus that 2x. So in this case, it doesn't matter which one visits which one, because they are equal. So if they are equal, let's just make a conclusion to say the denominator will always visit the numerator. Yes, let's maybe conclude it in that way. So can you see, we end up having 2 to the exponent. What is that minus that? Definitely 0 times. What is that minus that? Definitely it is 0. So you end up having 2 to the exponent of 1. We set anything to the exponent of 0, it's 1. Yes, I meant to say 2 to the exponent of 0, it's 1, multiplying to 3 to the exponent of 0 being 1. 1 times 1 is equals to 1. And that's how you work it out. I hope that makes sense. Maybe very quickly, let us now look at this example. Just want to zoom in there so that I've got enough space. Okay, then it's fine. Let's maybe look at this example where this is example C, and let us say for this example C you are given 16 to the exponent of x where we minus 1, and that is being divided by, let's say, 2 to the exponent of 4x where this is multiplying 32. Where are we going to start? A big question. So my advice is that you always start where you have the bigger bases, so that 16 you can try and rewrite it as something. We already know that 16 now is 2 to the exponent of 4. Everything else, you will rewrite it exactly as it is. So it mustn't be that you've changed something and then the x or the 1 or the negative disappears. It must just remain as it is. Then from there, you jump onto that part of the denominator where it looks like that 2 to the exponent of 4x. There's nothing that you can do there because it is in its smallest base. But the question now is, what about 32? I think 32 can be written as 2 to the exponent of 5. You can just check it, but if I remember, this is what 32 is. So now can you see, you have each expression in its simplest base or in its smallest base. Now that you've done that, all that you need to do is to apply the law. So remember, if you have a base to the exponent of 2, let's say an example, and then you may be having x plus maybe let's say 2. The law says this exponent will multiply each of those. It will multiply that, and again it will multiply that. So it's like you are having 2 that you need to multiply it by that. So you will definitely have to say that times that, that times that. That's what I'm going to do there, where I'm having the base of 2, and then that 4 multiplies that, it also multiplies that. That's why I end up having 4x where I minus 4, because 4 times 1 it is 4. Okay, and then what else do I have? I still have my 2 to the exponent of a 4x, but wait, this and that are the same basis, so that means I can just plus that. The reason I'm plussing is because I'm having the same basis. What do you do when you have the same basis? You add their exponents. So now in a situation where you are not sure in terms of which exponent is bigger, which exponent is smaller, which exponent has to visit which one, do not worry that much. If you are in that situation, always take the denominator and make it visit the make it visit the numerator. Then once you've done that, if you still end up having a negative exponent, I will then show you how you rewrite it as a positive exponent. So that means in this case, you can just say already you are having 2 to the exponent of 4x minus 4. Then you just take this exponent, you take it to the top, it changes the sign from being positive 4x to minus 4x. You do the same for that one, it goes up, it changes the sign to become minus 5. So that's how you would have to work it out. I'm just trying to check something here. Yes, okay, this looks fine, then it's fine. Let's see. I was just trying to verify if I did not make any mistake, of which I believe that I did not. Okay, then it's fine. So you look at 4x, which will minus 4x. So you end up having that 4x cancelling with that. It's like 4 minus 4 is 0. Then you end up having 2 to the exponent of what is negative 4 minus 5. Yes, I almost said 4. Negative 4 minus 5, definitely that will be negative 9. So you see, now you have it as a positive exponent. You always don't want to have your final answer as a positive exponent. You will therefore have to rewrite it such that you have that invisible one there, which is the one that remains at the top, and then this one you rewrite it there as 2 to the exponent of 9. You see, now you are having it as a positive exponent. So that's how you would have it as a positive exponent. One can still go further to say it's the same as 1 over 512. I don't know why here on the example that I'm having, their final answer is 2, of which I'm suspecting that is wrong, because when they were minusing the exponents, they ended up having 2 to the exponent of 4x minusing 4, and then they said into, not into, but minusing that denominator. So here, instead of a plus, they put a minus there. I think that's why, because they will end up having 4, not just 4, but not just x, but 4. They will end up having this, and then that. This will be minus 4x, and that will be positive 5, where that cancels with that, and then it's like 5 minus 4, it is that invisible one. So I think that's where they made a mistake on that one, but it's fine. Let's see. I want to actually verify if indeed what I've done is correct. So I'm just going to use my tactics to prove if what I've done is correct. So how you do it, you can substitute any value that you like in place of x. Maybe let's put 2 and not a big one. So that means you'll say fraction 16 to the exponent of 2 minus 1. Where you see x, you put 2. Then at the bottom it will be 2 to the exponent of 4 into 2, because where I see x, I put 2. Then that multiplies, let's see, that multiplies by 32. When I say it's equals to, it must give me that final answer being 1 over 512. Yes, it does. So that means what I've done is correct. They definitely made a mistake, and luckily I was able to detect the mistake. So if you want to prove whether your final answer is wrong or correct, it doesn't matter which value you use. Myself, I chose to substitute 2 in the original expression. You can choose 3, you can choose 1, you can choose any number that you like, as long as you won't choose one that will give you an error. If it gives you an error, then try a different value, just so that when you say it's equals to, you compare with your final answer and check if it gives you the same final answer. So take a screenshot of this. I think you might need it. And then let's see. I want to go back to allow you to take a screenshot of this. And once you've done that, I'll go back so that you can take a screenshot of this one. So I think by now you should be ready to try and attempt your short test. I'll do this for the last time so that you can quickly take a screenshot in case if I caught you off guard. Okay, That was the sound of the screenshot. I could hear you taking a screenshot, and then here's the last one. Let's see. Let me do that. Okay, then it's fine. Good luck, honorable member. We'll see if you are going to manage or not. I think for this one, I am out. Okay, so now I'm going to take you through exponential equations. Remember, the word equations, it means you are expecting to deal with something that has an equal sign. What do we do when we have a maths problem that has an equal sign? We do know very well that we need to solve. What are we solving? We always solve for the unknown, which is represented by the letter, and that letter could be any letter from A up to Z. Doesn't matter whether it's a capital letter or a small letter. What we know is that our final answer should be letter equals a number. That's how you know you are dealing with an equation. Your final answer will be a letter. It's equals to a number. That letter could be A up to Z. So again, the word exponential, it should just remind you that you might expect that letter to be in the position of the exponent. Remember, a power, it is structured in this format where you have the base and then you have an exponent. This is called a power. So this is where you are now going to be having your A up to Z. So just be aware of that. Maybe let's start with our first problem, and then you will have an idea of what I'm talking about as we continue. So the first problem, let's say we are having 2 to the exponent of x, again raised to a power of 2, and this is equated to 32. Every time when you are given a math problem and you do not know where to start, always look for where you are having the brackets. That will be your starting point. Why the brackets? Because BODMAS starts with a letter B. That B stands for brackets. So you look at this structure where you are having the brackets, and you remember that law which says you multiply their exponents. Then you end up having 2 to the exponent 2x, because 2 multiplying by x is 2x, and this is equals to 32. So you no longer have the brackets. What you need to do is just to make sure that the bases are the same. So you might need to rewrite this 32 in a form of something to the power of something. Based on my experience, because this 2 has to be the same as the other one on the other side, then you might find yourself having to figure out what is 2 to the exponent of something that will give you 32. If you say 2 to the exponent, let's start with 4, it gives you 16. Definitely is going to be 5, yes. So that means 2 to the exponent of 5, it is the one that gives you a 32. So now that the bases are the same, they fall away. What do? You equate their exponents. So that means you end up having that dividing with that. Why? Because it has to cancel. Whatever that you do on the left, you do on the right. So you had to divide by that 2 so that it cancels completely. Then now you see you have letter equals a number. If you punch it on your calculator and it gives you a decimal, just leave it as a fraction. Don't need to write it as a decimal. So that should be the end of it. I'm just hoping that as I work out these problems, I do not make some mistakes. Just keep an eye on that. But definitely, if you follow the math procedure, you will never go wrong. So just have to make sure to be extra attentive. Likely this one, I can already see that it is correct. Okay, so now problem number 2, let's say you are given 3 in the brackets. Let's say it is 3 to the exponent of x, and then again we square that. Maybe let's equate it to 2, 4, 3. First thing first, I think we might as well just remove that 3. How do you remove it? You divide both sides by exactly that so that it cancels. That's how it disappears. Then you remain with your 3 to the exponent of x squared equals, what is that when you punch it on your calculator? You'll say 243 divided by 3 gives you 81. Then now it's like you're doing example number 1 where you multiply the exponents and then you have 3 to the exponent of 2x, which is supposed to be equals to, then 81, it will definitely have to be 3 to the exponent of something. Let's see, 3 to the exponent of, maybe 4. Yes, 3 to the exponent of 4, it is the one that gives you 81. So it therefore means you have 2x, you equate it to 4. Why? Because the bases are the same, they fall away. So that is the main aim, to make sure that the bases are the same so that they fall away, and then you divide by 2 so that that cancels completely with that into that, it's equals to 2, and that is the end of that one. Let's see, maybe I can squeeze in. Okay, let's do problem number 3, where you are having 5 to the exponent of x, where you minus 1, close that, and then this is being equated to 125. Again, you are having the brackets. How do you work out this one, where it is not just a letter, but it's a letter minus a number? You will do that by that by that, meaning you multiply each term. So you have 2 multiplying that x, it becomes 2x. You have that one multiplying that 2, it becomes negative 2. Yes, this should be equal. So I think 125, let's straight away work it out. 125, it should definitely be 5 to the exponent of something, so that these bases are the same. What will it be? Let's say 5 to the exponent of 3. Yes, so that means it is 5 to the exponent of 3. Now the bases are the same. What do? You equate their exponents. So now we equate their exponents, and then you start solving. It's like now you are having your linear equation, where now 2 goes to the other side, it changes a sign, it becomes a plus, and then you are having 5 there. You need to remove that 2 so that it cancels completely. Remember, main aim is for you to finally say a letter equals a number, and that should be the end of it. And quickly just double check that by that by that. Yes, that to the that. And then you've got the exponents being equated, and then you solve. That goes to the other side, becomes 5, and you divide by that, so it cancels, and that should be the end of it. Then now let's look at example number 4. Of course, I'm moving at a faster pace because this is connected to the lesson that we did on the laws of exponents and exponential expressions. So the example that I've done in the beginning, it is connected to these ones that I have done. So trust me when I say you just need to do the first few, and then with the others you need to redo them as many times as you can, so that you know, it becomes part of your DNA, where you just look at it and you know what you need to do. Then it's just a matter of you writing. So now let's say we have this being 4 into 2 to the exponent of x, and then raised to 3. Again, let's say 128. Okay, so if you have this, it looks like it is that one where we need to just remove that 4. Then you divide both sides by that so that it cancels, and then straight away we can multiply that by that. Then we have removed the 4 and we have removed the brackets, and then it ends up being that, which should be equal. Okay, what is 128 divided by 4? Definitely that is 32. So next step, I think you now have an idea of what needs to be done. It will have to be 2 to the exponent of something. Let's try 4. 2 to the exponent of 4. Nope. Oh yes, it's 5. We've done it before. To the exponent of 5. So the bases are the same, they fall away, and then you remain with 3 to the exponent of 5. You now equate the exponents. Now you need to remove that 3, so that you will say letter x is equals to 5 over 3, and that is the end of it. Not sure if there's a space there to squeeze in another problem, but it's fine. I'll just go back to number 1, and then I will do example number, which example number is this? Okay, looks like it's example number 5. Okay, we have 2 into 4 to the exponent of x. This should be equated to 32. Then again, let's remove that 2. How do you remove it? Divide by 2. Then you have 4 to the exponent of x. What is that into that? Definitely it is 16. Then you have your 4 to the exponent of x. I think 16, definitely it is the same as 4 squared. Then you have your x being equated to that 2, and that's how you simply and easily work it out. So now let's jump on to problem number 6. Let's see how it looks like. For problem number 6, we have 3 to the exponent of 2, where we minus x, and this, it is equated to an interesting one. It is equated to 1 over 9. Okay, so in this case, remember you are dealing with the exponent. So anything which is a fraction, you try by all means to convert it from being a fraction to being an exponent. So 1 over 9 is where we are going to start. And what we are going to do there, you see there 9 can be written as 3 squared. So I haven't changed anything. I've just written it in its exponential form. So now what I don't want, it is the fraction. So how you remove the fraction? Obviously, this is how it works. Your denominator, you will write it as the numerator, or in the position of the numerator, but with its negative exponent or with its opposite sign. So you will have that one, which is that one there, multiplying. Now you just rewrite this in its exponential form, but in the position of the numerator. So that's what happens there. So when I say you rewrite it with its opposite sign, it means if it was a 3 to the exponent of negative 2, you were going to still write it in that position, but with its opposite sign, meaning it was going to be a position. So in short, you just rewrite it there, and then you just change its sign from negative to positive, or from positive to negative. It depends on what it was originally. So you see now, this times that, definitely anything that is being multiplied by 1, it doesn't change. So you now have your 3 to the exponent of that being equated to 3 to the exponent of that. Bases now are the same. So you end up having your 2 minus x being equals to negative 2. So you can take that 2 to the other side if you want to take a long drive. And then you end up having negative x equals to negative 4. Just be aware that you have invisible 1 there that you will need to remove. That is why you divide both sides by that negative 1, where you will say your letter is equals to, that cancels, it goes 4 times into 4. That is 1. That goes 4 times into 4. So that is the end of it. Not that it's a lengthy calculation. I just had to make sure that I do not skip any steps, so that you've got it on record. Okay, so now let us quickly check. Problem number 7. For problem number 7, you've got 5, and then let's say 5 to the exponent of x, that we plus it by 1, and this is being equated to 625. Okay, first step, I want to remove that 5. That's why I'll divide both sides by that 5, so that it cancels, and then I remain with 5 to the exponent of that being equals to 625 divided by 5. It is 125, and I think I've done 125 before, where I just have to now rewrite that as it is and say 5. Why 5? So that the bases are the same. I think it's 5 to the 3. I think it's 5 to the 3. Yes, that gives you 125. And then you are having x plus 1, which is being equated to 3, because the bases are the same, they fall away. So you have your x now being equals to 3, and definitely minus 1, and then your x will therefore be equals to 2. And that is the end of it. Hope I've done it correctly. So let's now look at example number 8. I think, yes, example number 8. Let's see. Okay, let's say you are given 7 to the exponent of x squared, and this is equals to 1 over 49. Okay, it shouldn't be complicated, because I know that 2 has to multiply that x. Then I have 7 to the exponent of 2x, which should be equals to 1 over, definitely 49 is 7 squared, that I know. So again, I will still do the same way. I have to rewrite this as that invisible 1 multiplying 7 to the exponent of that, just like I did with which example? I think it was example number 6. So the bases now, they should be the same, because this one multiplying by that, it doesn't change that, it just remains as 7 to the negative 2. Now the bases fall away. You can equate the exponents. Then now let's remove that 2 or detach it, so that we end up saying letter equals a number, and that is the end of it. That is how you know that you've dealt decisively with an equation. You must be in a position where you have a letter being equals to a number. Okay, let's jump on to maybe example number 9, where we have 4 to the exponent of, let's say, 2x minus 1. We equate this to 1 over 4. Again, it shouldn't be complicated. Just like I've done there, I will therefore end up having 4 to the exponent of negative 1, because remember, you have invisible 1 as your exponent there, and we know that 1 doesn't change anything. So that is why now I will end up having the same basis. Then all that I have to do, it is to just equate their exponents. Then I end up having 2x, which should be equal, you take that one to the other side. What does it become? Take it to the other side, it looks like it will be negative 1, that you plus it with 1. Then you have 2x, which should be equal, so I think that should be 0. Then you need to divide both sides. You have your x being equals to 0. Yes, 0 divided by anything, I think it is 0. 0 divided by that, yes, definitely that is a 0. Let's see. Okay, let me look for a space where I can squeeze in the next problem. I'm not sure if I've got enough space there. Okay, problem number 10. I think I will do 2 more after number 10. Let's say we have, okay, 3. Then let's say that, and then 1 over 3. This is equated to 1 over 3. Again, I will need to remove that. So that means I will need to divide both sides by that 3, so that I will just end up having that 9 to the that being equals to, then what is 1 over 3 where you divide it by that 3? Okay, it gives 1 over 9. It gives 1 over 9. Already, it looks like I know what the answer would look like. Definitely, it will be 9 to the exponent of x minus 3, which should be equals to 9 to the exponent of negative 1. The bases now are the same. What you do, you equate their exponents. And then you end up having your x being equals, you take that to the other side, it will be positive 3, so it's like positive 3 minus 1, which will therefore be equals to 2, and that should be the end of it. Which other example can I squeeze in? Let's see. I'll just create some space there. Okay, then it's fine. Let's do, I think it's example number 11, where you are having 2, which is inside the brackets, to the exponent of x plus 2, and then that is being raised to 2, and then this is equated to 2, 5, 6. Okay, again, that by that, that by that. So you end up having 2 to the exponent of 2x that you plus it by 4, which should be equal. What is 256? 256, will it not be 2, let's say, to the exponent of, what about 8? 2 to the exponent of 8, 256, yes. 2 to the exponent of 8, it is that. I just had to guess there, a bigger exponent. So you can just guess and say 2 to the exponent of maybe 5. If it doesn't work, you keep on adding until you get to that one. There's another way in which you can easily punch it on a calculator and then it gives you s2 to the exponent of 8. I will show you that at a later stage. But for now, this is the basic way of doing it. So now the bases are the same. You know very well what happens. They disappear, and then you just equate their exponents. So you end up having 2x, that should be equals to this, you minus 4, and then it becomes 4, and then you divide both sides by 2, and then that into that, it is 2. That should be the end of it. So maybe let me do one more problem. I'll just use that space there in between. So let us say this being the last example, let's say you are given 6 and then you have 3 to the exponent of x. Just close that, and then we equate it to a fraction being 54 over that. Okay, what am I going to do here? I will definitely divide both sides by 6 so that I remove it. So you can see there's a consistent pattern here where things repeat themselves. So already I had 54 over 6. Now on the side I'm just going to divide it by 6. Let's see what it gives me. Wait, did I copy the question correctly? Might need to verify that. Where will I get that problem now? Okay, let me quickly check. Okay, I think I've got an idea. Let me go back to the previous page. Oh yes, 54 over 3. That should be the correct equation, not 54 over 6. So I will just need to erase that and that, and then say 54 over 3. So that means it is the one that I divide by that 6 that is going to cancel on that side. Yes. So when you say 54 then over 3 and you divide it by 6, it gives you 3. So that means you are having 3 to the exponent of x, which is the one being equated to 3, obviously to the invisible 1 over there. So that you end up having the bases being the same and they fall away. Then you've got your x value being equals to 1, and that should be the end of it. I'm hoping that I've done everything correctly. Maybe let me do this so that you can take a screenshot. Otherwise, if they are too small, then just make me aware so that I can share these calculations on the website, and that's where you should be able to access them. So I think on my side, I've done all the examples that I wanted to do for now, and then I will just end it here for these exponential equations. Okay, so now I'm going to teach you the equations with fractions. But this time around, we're going to look at some equations where multiple terms are in a form of a fraction. So maybe without wasting much of our precious time, let me just write down this one and say, if you are given 1 over 2, let's say this is added to x over 2, and this is equated to, maybe this time around, let's say 2 over 3. Just have a look at this and ask yourself in terms of where you would start and how you would work it out. Of course, there are many ways in which you can work it out. So what I'm going to try and do is to take you through a safe method. So a safe method would be one that you can use for any type of an equation where fractions are involved. Please trust me when I say I've done a lot of math problems and I've done a lot of mistakes, and I got to a conclusion to say, actually, regardless of how it is given, how easy it is or how complicated it is, I will always follow this way of doing it, because when I do it this way, I'm able to solve any type of a math problem similar to what you are looking at now. So this is the best way to go about it, and I will apply this type of working for all the problems that I'm going to take you through. So first thing first, look for that fraction that has a letter, and then leave it on the left. All the fractions which do not have the letters, meaning which are just the numbers, take them on the right hand side. So when I look at this, it's like I'm having, let's say, 2 plus x is equals to 3, where I'll obviously need to say x, leaving it on the left hand side, and then I have got that 3 minus 2, which will end up being 1. That's how I look at it. Doesn't matter whether it's in the form of a fraction or not. Letters one side, numbers one side. Let's try work it out in that approach. So that means this x over 2, you can say it is equals to, already you have 2 over 3 on this side. Then what you can do, it is 2 minus that 1 over 2. So that means you have your x over 2 there being equals to, then you say 2 over 3 on your calculator minus 1 over 2. What do you get? So you end up getting negative 34 over 3. So now you can either cross multiply, or if you don't want to cross multiply, you can rewrite it in that format of a coefficient x being equals to the whole of that. So this is what I mean. You have an invisible one there. So when something is written like that as x over 2, it is the same as that invisible 1 over 2 multiplying by x, which will be equals to whatever that you are having on the right hand side. Then what you do, you remove that fraction. Remember, whatever that you do on the left, you do on the right. So because you are removing a fraction, that's why I put it inside the bracket, so that I will say that and that cancels. Then you have, on your calculator, you will just punch it like this, where you say negative 34 over 3, and then you can do this divided by, you open a bracket, and then you say 1 over 2. Just make sure that you have a calculator that is able to do the fractions. So I will start by saying negative fraction, then you say 34 over 3, and then on the side you do the divided by, you open a bracket, you do the fraction, and then 1 over 2, you close, you say equal sign, then you end up having a final answer where your x is equals to negative 68 over 3, and that is the end of it. So without wasting much of our precious time, let me quickly do example number 2, and then we will see how to work it out. So let's say you have p over 4 minus 1 over 2. Let's say maybe this is equals to 4 over 5. Okay, again, I'm sure by now you realize you've got an invisible 1 there. So let's just write it in that proper way of saying 1 over 4. It is therefore multiplying that p. We will say equals to not 5 but 4 over 5, because that's what you have already. And then that 1 over 2, it goes to the other side, it changes the sign, it becomes 1 over 2. So you still have your 1 over 4p there, which is equals to, on your calculator, 4 over 5. On the side you plus it by 1 over 2, and then you get 13 over 10. So now you just remove that coefficient of 1 over 4, but just remember to put it inside the brackets. Whatever that you do on the left, you also do on the right. So can you see now that cancels completely with that? You remain with p, which is what you are looking for. And then you will just punch it like that, where you do it this way. So I'm writing this so that you can have an idea of how you punch it on your calculator. So on the next calculations, I'll just do the final answer there. So that means you will say 13 over 10 on the side, you divide it by 1 over 4, which is equals to 26 over 5. And that should be the end of it. So without wasting much of our precious time, let's jump on to example number 3, where you have, let's say you have negative, okay, I'll just modify the equation there and say maybe over 3, and then let's say minus 1, maybe this time around, let's say y over 2. Yes, let's do it this way. What I know is that I want to have all the letters on the one side, numbers on the one side. So already this one of 2 over 3, I will rewrite it in this way of that format. Then this one of invisible 1 y over 2, I will have to transpose it or take it to the other side, and then it has to change its sign. That's why it becomes negative 1 over 2, which is the one multiplying y. And then I will equate it to this one. I will take it to the other side because I want it to be on one side, as it is a constant or a number. And then it will just be positive 1 because it changes the sign when it crosses the border. Okay, so now what are we having there? Let's see. We end up having that negative 2 over 3 minus 1 over 2. So you punch it on your calculator, negative 2 over 3 minus 1 over 2. What do you get? You get negative 7 over 6. Remember your y there, which will be equals to 1. Then the last step is for you to just remove that. So it is that negative 7 over 6 that you want to remove completely. Remember, whatever that you do on the left, you do on the right. So that should cancel completely with that, and then you've got your y, which will be equals to, you'll say 1 divided by, in the brackets you have negative 7 over that 6, and then you get negative 6 over 7, and that should be the end of it. So can you see, same pattern, honorable member, same approach. Let's do example number 4. Maybe after this I'll do one more, and I think you should be in a good position to attempt similar problems. Maybe here, let's say we have negative q, we minus it by 3, and then let's say here we have 1 over 3 q. So you can see that it is any letter that can be used. So what I know is that I want to have these letters on one side. So I'm already having negative 1q there. Then I will take this to the other side, where I will take that 3 to the other side. It changes a sign. So you must just always remember that when something goes to the other side, it changes a sign. If you forget that part, then it means from that step going down, everything is wrong. So now remember, you have invisible 1 there. So it's like you have negative 1 minus 1 over 3, which is equals to, it therefore gives you negative 4 over 3q, which should be equals to 3. Then what you do, all that you do is just to remove this coefficient, which is negative 4 over 3. Remember, whatever that you do on the left, you also do on the right. So that cancels completely with that. Then you end up having your q, which is equals to, what will that be? 3 divided by, in the brackets, you have negative 4 over 3, which is equals to, this is what I'm getting, negative 9 over 4. And that should be the end of it. So maybe very quickly, let's do one more problem. And this should be problem number 5. Let's see how far we can go. Let's say you have negative 2, where we plus k over 2, and this time around let's equate it to 0. So based on what I'm saying, it means you will need to rewrite that fraction as 1 over 2, that is being multiplied by k, which should be equals to, you take 2 to the other side, it changes the sign, it becomes 2. What's next? You therefore divide by that fraction, because you want to remove it. Whatever that you do on the left, you also do on the right. So that means you divide that side, you must also divide that side. So it cancels out, you remain with your letter. Then you'll say 2 divided by, you open your bracket, then you've got your 1 over 2. Even though you may know what it will give you, I would advise you to just punch it on your calculator. You will never know. The moment you do too much of mathematics, sometimes you may forget some things, and then you try to use your head, then that's where you lose it. So just make sure that whatever that you are having in mathematics, you always punch it on a calculator. It doesn't matter if it's 1 plus 1. Just move it there. It will definitely give you the correct answer. So I think I am done for now. Let me just quickly verify if I've done everything correctly. That number 1, that to the other side, and then I divide that, cancel, and then punch that. That 1, that to the other side, positive, and then that cancels that. Okay, number 3. So what you can do for now is just to take a screenshot. Just take a screenshot in case if you will need this information to study as you prepare. And that other one, let's see, that to the other side. Yes, it changes the sign, that and that cancels, and then that to the other side, it changes the sign, that cancels, yes. And this one, that to the other side changes the sign, and that cancels, yes. It looks like I've done everything correctly. Okay, then it's fine. I'm done for now.